The last session we have discussed first 5 questions. Then question 6 onward. A ball bearing is released into a measuring cylinder with oil. So there's a ball bearing which is released uh, in a measuring cylinder which is filled with oil to increase the time. So what we want the ball to take more time as it falls. So we want to increase the time interval. So if we want to increase the time interval, we have to increase the viscosity, because, or we want to reduce the speed. If we reduce the speed, or if we increase the viscosity, the speed will reduce. As the speed reduces, it will take more time. So if we increase the temperature of the oil, what happened to viscosity? The viscosity will decrease. If the viscosity decreases, the speed will increase. So it will take short time. So A cannot be an answer. Viscosity of the oil. So if we increase the viscosity of the oil, the terminal velocity will decrease and the time it will take to fall will increase. That's why B is the right answer. Another question. Question 7A1. A small solid particle is falling through a water. Add a label arrow to show diagram how forces are acting. So if it is falling through a water, so weight will act downward. The upthrust, which always act upward, and viscous drag or drag force will be there, which try to oppose the motion that is also acting upward in case if the object is moving down. Explain the condition for particle to fall at a terminal velocity. If this particle is falling at a terminal velocity, first thing we have to mention that there should be no resultant force. Act on the particle. And the second thing we can mention that the weight is equals to drag force plus upthrust. Flowing water, can be used to move a solid particle. The diagram shows water moving horizontally. Laminar flow is there. Add a diagram to show the path of the particle. So what will be the path of the particle? Because the particle is falling and the water will push horizontally towards right, so it will follow a trajectory of projectile, or follow a projectile motion, because it will have two components. One, the weight acting downward, and the horizontal force will be there from the particles of the fluid of water, which cause it the parabolic path or projectile motion. Complete the diagram to show water moving with turbulence. So how we represent the turbulent flow? So we will abrupt change in the direction as well as the speed of the particles. So when the particle abruptly changing their speed and direction, we call that as turbulent flow. And turbulent flow, it will apply greater force as compared to laminar. Then we have to describe difference between laminar flow and turbulent flow. So what is the difference between a laminar flow and turbulent flow? In a laminar flow, the particle move for a certain section, they move at a constant speed. They does not move abruptly. No eddies are there. So when we mention the answer for laminar, no abrupt change in direction and speed of the particles, whereas turbulent, there's an abrupt change in direction and speed of the particles. The next one suggests why a turbulent flow may be used to move a small solid particle. Because what happens when there's a turbulent flow, the turbulent flow, it will apply, like the particle will have more collision with this solid. So it will exert, so turbulent flow, there's a continuous change or disrupt the particle back into a flow. So it does not allow the particle to stop. So in turbulent, more force and continuous force on the particle to change direction. So the particle does not stop. Is it clear? Question 7, the last two parts. Any doubt till this point? So the next one, a small bubble is rising at a constant speed. When something is rising at a constant speed, so it means there is no resultant force. And because it is rising, so when it is rising, weight is acting downward. Upthrust is acting up. And viscous drag also oppose the motion. So viscous drag, because if it is moving up, the viscous drag always oppose the motion. So in this example, the drag force or viscous drag will act downward. So the drag force and weight acting down and upthrust is acting up, and weight plus viscous drag, because they're in the same direction, should be balanced with the upthrust. So the option which is the right one, that is upthrust is equals to weight plus viscous drag, or C will be the right answer. Explain the difference that using a hot pan would make to how oil spread. Example, if we make a pan hot first and then we add oil, what change or what is the difference we'll observe? So when the pan is hot, the viscosity of the oil decreases, and when the viscosity of the oil decreases, it will flow quickly or it will spread quickly. So when the pan is hot, the viscosity of the oil decrease, so the oil will flow at a greater rate and spread quickly. In question 10, in a game of table tennis, the ball is hit from one end of a table to over the other over a small net, making a table tennis ball spin when it is hit can affect the flight. Like example, the distance it travel or how much time it will remain in air. That flight time can change if we spin the ball. The diagram shows the path of air around a spinning ball. So there's a spinning ball and the path of air is shown. The ball is moving towards left and the fluid will be in opposite direction. The fluid flow. So what is meant by laminar? Laminar means no abrupt change and turbulent means there will be abrupt change. The ball is spinning in the direction as shown. Suggests why there is a large region of turbulent flow at the top of the ball than at the bottom. Like here, you can see at the top of ball there is a greater large portion is turbulent as compared to that of the bottom. So when you check this movement of the surface, like this is a surface of the ball. So this surface of the ball is moving opposite to the fluid. So there will be more air resistance. When there is a greater air resistance, that will increase the turbulent flow. But when you check the lower part, as the ball is spinning, the direction of the movement of the surface and the direction of the fluid, it is same. So it is having less air resistance. That's why this region, it will have like a more or greater laminar flow as compared to that of top region. Is it clear? That why greater eddies or random movement of the air at the top compared to that at the bottom. The diagram shows the air is deflected upward after passing. Explain why this means there will be a downward component of the force in addition to weight. So what will happen, as we just discussed, that because the direction in which the surface of the ball is moving at the top face is opposite to the direction of the fluid, so there's more air resistance. And there's also another thing, according to Newton's third law, action and reaction forces are equal but opposite in direction. So if air is moving randomly after, so what happened, the ball will apply force on the air particle. So these air particle will push the ball in opposite direction. So same thing happened here. The air particle are moving up. As a result, according to Newton's third law, the air particles will apply a downward force. So weight is already acting downward, and there is a component or there is a force due to the or a Newton pair force. So that is also acting downward, which will be additional part to the downward component. So when we write the answer here, that air is deflected upwards. If a ball is pushing the air up, the air particle will push the ball downward. So according to Newton's third law, the air is pushed up by the ball. So the ball will apply, so the air particle, same force in opposite direction, which is downward. So as the air particles are moving up, there will be a downward force from the air particle into the ball, and that will increase the total downward force. So force by the ball on air is upward, that's one mark, and then the second one is force by the air on the ball is opposite direction or downward. So that's why the ball will have a greater downward component. In question 11, when beer is being brewed, it can contain bubbles and the gas rises through. So if the gas is rising, upthrust will act upward, weight will act downward, and drag force or viscous drag will also act downward. So for a gas bubble, it should be like this. But for a solid particle which is moving down, because if the particle, this is for a particle which is rising. But for a particle which is moving down, the weight will act downward, the upthrust will act upward, and the viscous drag will also act. So direction of the upthrust and weight will not change. Only thing what changes is the drag force. It depends on the direction of the motion. If the motion is direction of the motion is downward or it's sink, then the drag force is up. If it is rising, the drag force is down. So for a gas bubble, upthrust is equals to weight plus drag, and for solid particle, weight downward is equals to upthrust plus drag. So B is the right answer. In question 12, car engine use motor oil as lubricant to reduce the friction. Motor oil needs to operate over a range of temperature because at 0 or below, when the engine started, but up to 160 when the engine is running, at all the time motor oil needs to be thin enough to allow the parts to move smoothly, but thick enough to remain on the parts. Explain why the engine oil may experience difficulty if the temperature becomes too hot or too cold. So what will happen if the temperature becomes too hot? Then the viscosity decrease, it will flow easily, so it will not remain on the parts. But if the temperature is too low or if it is too cold, then the viscosity will be high, it will not flow, so it will remain at certain parts, it will not flow easily to the all parts. So we can write so viscosity increases with decrease in temperature, or viscosity decrease with increase in temperature, or viscosity is inversely proportional to temperature. This will give you 1 mark. And then statement describe either what happened between the oil and the engine part. If it when it get too hot or too cold, like if too cold, the oil could be too viscous and it will not spread in the part. So if it's too hot, it will run off and it will not remain or stick to the parts. In an experiment, a small metal is dropped. The time taken for a ball is recorded. Experiment is repeated. Which change to the ball result with the greatest increase in time, decrease in time? So if you want to decrease the time to reach the bottom, so basically we want to increase the terminal velocity. We want it to flow easily. The upthrust, when we write the equation, for a ball which is falling, the weight is acting downward, upthrust is acting up, and the viscous drag or drag force will also act up. What about the upthrust? Upthrust depends on density of the fluid, volume of object, and gravity. So if you want to reduce, because we want greater resultant force, if we want a greater resultant force, we have to decrease the upthrust and we have to increase the weight. How weight can be increased? Weight is the formula mass into gravity. So if I increase the mass, the weight will increase. So there should be a greater mass. So either C will be answer or D. Then how to decrease the upthrust? Upthrust is density of the fluid, volume of object, and gravity. So if I decrease the density or the volume of object, the upthrust will also decrease. So when we decrease the volume, the upthrust decrease. So how we can decrease the volume? By reducing the diameter. That's why C is the right answer. Is it clear, this question? In question 14, lava is a molten rock which sometimes erupts from beneath the Earth's surface. As the lava cools, volcano forms. The shape of the volcano determined by the flow rate of the lava. The graph below shows how the viscosity of the two types of lava changes with temperature. So we have rhyolite lava and we have basalt lava. You can see the change with rhyolite lava is having a greater viscosity than basalt. So means basalt lava can flow easily because it's having a lower viscosity, whereas rhyolite lava it will flow at a slower rate because it is having higher viscosity. And change in the viscosity with reference to temperature for rhyolite lava is more as compared to that of basalt. So there are two types of volcanoes which can be formed by this volcanic eruption. One is the shield volcano, another one is the cone volcano. So both types of lava are at the same temperature as it reaches the Earth's surface. The shield volcano is formed from basalt. The shield volcano is formed from basalt, and it is obvious because it's having a lower viscosity, so it will flow. And whereas the cone volcano is formed by the rhyolite lava. Use the information in the graph, explain the shape of each volcano. So what we can say about this, so when we compare these, so what happened as the lava cools, the viscosity, because it cooled down, because it emitted hot, but as it cooled down, its viscosity increases. That's one mark. Then rhyolite viscosity is greater than basalt. So rhyolite will flow more slowly as compared to that of basalt. High viscosity will give a low rate of flow. So basalt flow a long way before it solidified or cooled, and rhyolite will flow at a shorter distance before it solidified or cooled. So this is a comparison that why a rhyolite lava leads to a cone shaped volcano and the basalt lava leads to a shield volcano. Is it clear? Any doubt till this point? In question 15, an investigation was carried out on a drag force acting on the swimmer. The swimmer pushed off from one side of a pool with his straight arms ahead and his velocity is measured as he is gliding through the water. Gliding means he's not using his arm to stoke or to swim. And there are two ways he's gliding. Gliding 1, gliding 2 shows the same swimmer, but different ways he's gliding. The glide one, you can see small, the velocity is decreasing because there's a drag force. But for glide 2, there's a greater change in velocity as compared to glide 1. Use the graph, describe, use the graph to describe and explain the motion of the swimmer when they're performing glide 1 and glide 2. So first thing, for both of the swimmers, the velocity is decreasing. So velocity is decreasing for both swimmers, or they are decelerating, and rate of change of velocity or deceleration is also, and rate of change of velocity is also decreasing. You can see The gradient, initially there is a steeper gradient, but the means greater angle, but the gradient is also decreasing. The drag force is also decreasing as the speed decreases, but glider 2 having a greater drag compared to glider 1 because he's having a large area or he's having more turbulent flow. So the force which is opposing his motion is much higher. In 1909, Robert Millikan did an experiment to find the charge on electron. The charge oil drops where between the two charge plate, the radius of the oil had to be determined so that its weight can be calculated. Before the plates are charged, Millikan observed how long it took for an oil drop to fall through an air between the 2 points. The terminal velocity, hence radius, could be calculated. Complete a free body force diagram for its falling through the air. So if it is falling through the air with a constant velocity, so weight will act downward and drag force or viscous drag will act upward. Explain why the oil drop reaches a terminal velocity. So why it reaches a terminal velocity? What is the condition for terminal velocity? Number one, there is no resultant force, or when the speed is increasing, the drag will also increase because the upthrust depends on density of fluid, volume of object, and gravity. And practically, drag will be upthrust will be much smaller compared to that of drag. So when the oil drop falls, its velocity increase, which increase the viscous drag or the drag force. So upthrust and the weight, or upthrust and drag balance with the weight, so no resultant force, and this will fall with a constant speed. In part B, an oil drop is traveling at a terminal velocity. The oil drop takes 11.9 seconds to fall a distance of 10 millimeter. Show that the terminal velocity is about 0.001 meter per second. Because it's a terminal velocity, so constant velocity whenever object moving with a constant speed is distance over time. So distance is 10.2 into 10 power minus 3 because it is milli divided by 11.9 second. So it will be 0.0012 meter per second. Because it's a terminal velocity, that's why we directly use the formula speed is distance over. Assuming that the upthrust is negligible, show that the radius of the oil drop is 3 micrometer, the density of oil is given, and viscosity of the air, it's a fixed value. It is 1.82 into 10 power minus 5. That's a viscosity of. So this is 10 to the power minus 5. So when it is, if we neglect the upthrust, so we can say weight is equals to drag force. What is the weight? Weight is equals to mg. And what about drag force? It is 6 pi eta r and v. This v is the terminal velocity. We need the radius. And what about the mass of the object? We have the density and we need a radius. So we can say mass is equals to density of the object multiplied by volume of object. And we can also say density of object and volume of object, it's a sphere. So it will be 4 by 3 pi r cube. So in place of mass, I can write density multiplied by 4 by 3 pi r cube multiplied by gravity is equals to 6 pi eta r and b. Now we simplify this. So this r will cancel with r cube, so r square will be there. Then this will be 2 and this will be 3. 3 will be multiplied there. Pi will cancel with pi. So we need, this will give us r square. So r square is equals to this 3 multiplied by 3, 9. Viscosity into terminal velocity divided by density of the oil and divided by the gravity, and we are left with 2 here only. And after substituting the value, just take a root, under root of this value, you will get the, so 9 eta v divided by 2 into the density and gravity will get the radius of this oil drop. And it is very difficult to measure the radius of such an oil drop directly. Suggest why. So what could be a reason why we are not able to? Because oil drops, number one, they are not perfect spheres. They can deform as they get charged. So they does not remain perfect sphere. So their shape changes. So they are very small, and so we don't have an accurate apparatus instrument to measure this very small value, as well as they might changes the shape as they're falling. So these are the two reasons it is difficult, which make it difficult to measure the radius accurately as possible. Number one, it is very small, the oil drop. So we don't have any accurate apparatus. The second thing, it changes the shape when it is falling. So it won't remain a perfect sphere. So if it will not be a perfect sphere, we are not able to measure it accurately. Explain why it is necessary for Millikan to maintain air between the plates at a constant temperature. Because what happens if air is not at constant temperature, if the temperature affect the viscosity, and as it affect the viscosity, the change in temperature will cause change in the viscosity of air, so the drag force will also change. So all the things are related. When there is a change in temperature, will cause change in viscosity, which affects the drag force. So all the things are related. Is it clear, this part? Then the last part, in practical, a student tried to model the Millikan oil drop experiment with a ball bearing, and he measured the distance between the two light gates with a known distance. Explain why this is not a good model of Millikan method. Because for a ball bearing, it won't reach terminal velocity quickly. That's one thing. Because it will have a high density, so there will be a greater difference in the density of air in the ball bearing, so it will not reach the terminal velocity. And ball bearing size or is larger, or fluid, the flow of the fluid might not be laminar, because Stokes law for a viscous drag is only applicable when there is a laminar flow. So what we can say, the ball bearing may not reach the terminal velocity. That's one thing. And the ball bearing Stokes law cannot be applied if ball bearing is flowing through a fluid, like example oil or any viscous medium, then it is applicable. But if I drop a ball bearing in air, air is not opposing, it's opposing the motion, but the drag force of the air is smaller as compared to that exerted by the viscous medium. That's why the ball bearing Stokes law cannot be applicable, because it has turbulent flow of air or fluid around it. So around the ball bearing, the flow of the air will be turbulent, but fluid, according to the Stokes law, the fluid flow around the object when it is moving, it should be a laminar one. And the fluid flow remain laminar when object is moving at a slower speed. Then the designer of a new lorry trailer claim it saved 10% of the amount of the fuel used to compare the traditional one. This is a traditional lorry, and this one is the new design, a new trailer. The photograph shows the air around the traditional and around the new trailer. So you can see traditional lorry is having greater region of turbulent flow, but new trailer more streamlined, like a jet or an airplane. The body is more streamlined, so it will have a less air resistance or leg drag force, or it reduces the drag force. So it reduces the drag force, it will experience less air resistance. So when the air resistance decreases, less energy is wasted. So these are the points you have to keep in mind. The new design, that is more streamlined, more curved, more aerodynamic, you can use the term. When the shapes support the motion, we call that as aerodynamic, like aircraft, airplane, jets. Their design is aerodynamic, which reduce the air resistance as much as they can. So less air resistance means less drag or friction, so less energy transferred to air from the lorry, or less work done against the air, or less amount of power or energy is needed to supply to the lorry to maintain a constant speed, because otherwise the energy will be used for overcome the air resistance, but in this case it won't be wasted. So these are some questions related to topic fluid. Any question or a doubt related to the class today?